Subclaim C, if I could sum it up in one word, it's all about reasoning. It's all about reasoning. And it's not just, am I right or am I wrong? Does it seem like a right answer? Does it seem appropriate? It's really about constructing an argument, critiquing the reasoning of others, and you notice that does not say critiquing the procedure of others. It's not finding the error in their computation. It's critiquing their reasoning. And then also attending to precision. And this is where you're going to see across the grade levels some very, very close similarities in terms of what students are being asked to do. And again, the stuff that they're going to be asked to do it with is the content in subclaims A and B that we just looked at. So let's look at reasoning for 6th grade. Now, I want to make a couple notes, and this is appropriate not just for 6th grade, but 7th and 8th as well. What you'll see underneath the left-hand column where it has the topical area is this 6C 1.1, 6C 2. The C comes from the assessment blueprint. These are not from the Common Core Standards document, but it's intended when they create the assessment blueprints, they give an idea of what the items are going to look like, the kind of thinking that will be involved. So you can pull out that assessment blueprints document and you can go through it and make specific reference to what the items will look like for this grade level. So I wanted to point out that reference is different. So as I said before, subclaim C is all about reasoning. So let's see what they're going to be reasoning about. In 6th grade, they're going to be reasoning, first of all, about properties of operations. And if you think about all that fraction stuff we started out with in subclaims A and B and some of the other additional content, certainly we need to be able to evaluate if students can construct responses based on properties of operations, relationship between addition and subtraction, relationship between multiplication and division. And so as you go across here, you're going to see things change in terms of a maturation of the student's thinking. So for instance, in level 2, as far as reasoning about properties of our operations, I may have a faulty approach, and when I move to level 3, I've got a logical approach. In level 2, I may have an incomplete or illogical progression. In level 3, that was level 2, in level 3 I might have a logical but incomplete progression. This is where, and the next one is where we need to have a discussion as math teachers, where in level 2 I might have major calculation errors. In level 3 I may still have some minor calculation errors, but I can maybe get through the majority of the problem. And the message they're trying to send there is that if students might make a simple calculation error in the beginning of a problem, for instance, but they carry that through correctly, they can still meet the standard of reasoning because they might have a logical approach, they might use some grade level vocabulary, they might have a partial justification of their conclusion. So what they're trying to encompass here is the entire reasoning kind of spectrum with respect to properties of operations. So that's important to note, and that's important to note when you're scoring student papers as a way of going through just your curriculum, is that you're valuing their thinking, you're valuing their solutions. That may require you to give some different kinds of tasks for student assessment, as well as limiting the number of tasks, because certainly you can't do 50 of these. Where you're going to have a logical approach and determine whether or not you're using grade level vocabulary. That's going to require careful selection of the tasks that you use. The other 2 areas then in 6th grade with respect to reasoning include the use of diagrams and concrete reference that include, for instance, if there are tools provided on the screen for students to use, if there's diagram, number line, coordinate planes, how well they're using those. And then also, lastly, but possibly most importantly, is whether or not the students can distinguish a correct explanation or reasoning from reasoning that is flawed. So the student may have a complete response, but they might they might have made a wrong assumption. That's a difference than having them, evaluate the validity of others' approaches. So what you want to see there is whether or not they're critiquing others' responses. That's a great way to end class. And again, as I said before, this is not just this is not just saying, well, you didn't carry a 1 when you added 9 plus 7, as a simple example. It would be something to the effect of, well, they multiplied those two values together when they really should have added those two values, or they used the volume formula when they really were trying to find surface area, so they were finding the wrong characteristic. So, or they used a graphical representation when they should have used a tabular representation. So I'm going to encourage you in subclaim C, and this is for all grade levels, not just 6th grade, to really look at what kind of high level reasoning, not just the procedural reasoning. Okay. Now, an important thing to note as you look at subclaim C for 7th grade is there's a whole lot of similarity as subclaim C for 6th grade. And in 7th grade, we will have a reasoning topical area of properties of operations again, and you'll see very similar. That was done intentionally so that the consistency of what is valued of reasoning stays the same across grade levels. And so if I can get partial credit, if you will, for a minor calculation error in 6th grade, it's still gonna be that way in 7th grade. Now, these aren't going to be problems where the goal is to get 57.5 as the answer. These are going to be problems where you have to draw conclusions and you have to make analysis. And so a minor calculation error is not really impacting your overall understanding of the concept at hand. And similar to 6th grade, the other areas for subclaim C are those diagrams and concrete reference, use of those number lines and so on and so forth, as well as distinguishing that correct explanation or reasoning from flawed reasoning. So again, what you see is a consistent commitment to helping students develop this reasoning in very much the same way in 6th grade as in 7th. And as I mentioned before, so what is the reasoning they're going to be doing it with? The content that we just looked at in A and B, subclaims A and B. 8th grade subclaim is where things get a little bit different. Because of the focus and the shift to a lot of algebra in 8th grade, you'll see that I'm not going to demonstrate as much, understanding of, the properties of operations anymore, because I've moved on and I'm really focused on graphs and equations, overall reasoning that involves my logical approach to whether or not something's linear, whether or not something is algebra or not, as well as then geometric reasoning. Am I getting a complete response based on applying a geometric principle? Am I just looking at specific instances? Am I identifying and describing errors in solutions? And those three areas are the only ones for 8th grade. So we have this graphs and equations, as you can see here, but you can see there is a similar level of understanding required of students in terms of how they create a solution method. And this kind of is parallel to 6th and 7th grade, except now we're doing it with graphs and equations. We're using that principle that the graph of an equation is the set of all solutions. And for a lot of students, that is a very difficult concept for them to grasp. And that's why they don't use it when they reason, because they see a graph of an equation as just being a line in and of itself. So it's important to take a look at this subclaim C as a way to kind of evaluate whether or not the linear equation situations you're giving to students are whether or not kids are doing it in the right way. You're not always going to tell them that it's linear, and you want to be sure that you're taking a close look at, do I have an understanding of what the relationship is being demonstrated, as opposed to just always being given the relationship. Here's an equation line. Well, you might want to give them a phenomenon and ask them if it's linear in nature, and they have to reason through that. And are they reasoning in a general kind of overall logical approach, or are they stuck in the rut of this specific instance? So that's